You've trained a GAN and it's spitting out images. Now the hard question, are they any good? You can't just compare pixels because two gorgeous images of different faces share almost no pixel values, and paying humans to eyeball thousands of samples simply doesn't scale. So how do you put a single, trustworthy number on the quality of a whole generative model? That's the job of the Frechet Inception Distance, or FID, the score that quietly decides which image generators win the leaderboards. Let's break it down. At its core, FID is a pipeline of 4 moves, and it never once looks at raw pixels. Follow it one stage at a time. Start on the left. We take a big pile of real images and a big pile of generated ones, and push both through a pre-trained Inception network, an image classifier originally trained on ImageNet. We're not using its final label, though we're borrowing its eyes. Move across. From deep inside that network we read out the feature activations, a long vector of high-level descriptors for each image, capturing things like texture, shape, and content rather than individual pixels. Now every image is a point in a rich, meaningful feature space. Now we summarize. For the real images and for the generated images separately, we model their clouds of feature points as a multivariate Gaussian, computing a mean and a covariance for each set. The mean captures where the images sit on average, the covariance captures how they spread and vary. Finally, the payoff. We measure the Frechet distance between those two Gaussians, a single number for how far apart the real and fake feature distributions are, in both their average and their spread. Lower is better, and a perfect 0 would mean the generated statistics exactly match the real ones. So why go through all that machinery instead of something simpler? Here's the contrast side by side. Comparing images pixel by pixel simply doesn't work. Two beautiful faces can share almost no pixel values, so a raw pixel difference punishes good images for merely being different rather than being bad. And hiring people to score thousands of samples is slow, expensive, and inconsistent, so it never scales to the constant evaluation research actually needs. FID instead compares whole distributions in feature space. It asks whether the entire population of generated images carries the same statistical fingerprint, the same average and spread of deep features, as the population of real ones. That single distance rewards images that are both realistic and varied, and it lines up reasonably well with what humans judge as quality. Boil it down, and 3 ideas define this score. Compares deep feature statistics, not pixels. By reading Inception's high-level activations, FID judges images on content and texture, the stuff humans actually notice, instead of raw pixel values that punish harmless differences. Lower means the distributions are closer. A small FID says the generated feature cloud sits right on top of the real one, in both its center and its spread, and a perfect 0 would mean a statistical exact match. Captures quality and diversity at once. Blurry, unrealistic samples shift the mean, and mode collapse, a lack of variety, shrinks the covariance, so FID punishes both, which is exactly what its predecessor, the Inception score, missed. The catch, it needs tens of thousands of samples to be reliable, and it inherits the biases of ImageNet features. Alright, let's lock in the essentials. The Frechet Inception Distance is the standard metric for judging how good a generative model's images are, from GANs to diffusion. It runs real and generated images through a pre-trained Inception network, models each set's deep features as a Gaussian, and measures the distance between them. Lower is better, and because it compares full distributions, FID rewards both realism and diversity, punishing blurry samples and mode collapse alike. As caveats, it leans on ImageNet-trained features, needs a large sample to be reliable, and judges the population rather than any single image. If grading AI this clearly is the kind of thing you enjoy, there's plenty more waiting for you at Standarity.com. See you there.